In this video, we're going to talk about volumetric analysis. And this is an experimental technique that is used to quantify or measure physical quantities such as mass, volume, and concentration of chemical substances. Now, these chemical substances we're trying to talk about, they're those reagents or those substances that are used for chemical reactions or chemical synthesis. So they're particularly important. You just need to bear that at the back. Now, considering mass and volume as well as concentration, there is actually some couple of equations you would need to know in order to really be very versatile in volumetric analysis. So let's talk about mass. There is something called molar mass. And molar mass, sometimes represented as mm in lowercase, that is written as mass. Now, what I mean by that is reacting mass or normal mass divided by the number of moles. If you switch these places with the number of moles and the molar mass, you're going to have a new representation. N will be equal to m divided by mm, which is actually where they brought the formula or where they found the formula for number of moles. Now from here you can actually find the unit for molar mass. This stuff in chemistry is actually measured in grams, that is mass, and the number of moles is basically just measured in mole, so you just have a mol. That is why the unit for molar mass is gram per mole, something like this. So as far as we're talking about mass, all these parameters, all these formulae, you need to know them, okay? So we're actually going to come to use them later on, but just to place them at your back somewhere. Volume. This is actually very needful. Volume and concentrations. They're actually sometimes going hand in hand. There is something called molar concentration, okay? Molar concentration most times is typically represented as a C, and that is equal to the number of moles divided by the volume in whichever substance is dissolved or is actually thrown into. Now this volume particularly has to have the unit dm cube. Now you need to know that dm cube is the same thing as liters. So if you don't want to call it dm cube, you can actually call it as liters. These two quantities, they're actually the same thing, or units rather. These units are the same. So let's say we plug it in to find out what will be the unit of molar concentration. So this is the number of moles. I think I need to write it better. You would have a mole, which is obviously mol. That will be divided by dm cube. Okay. Therefore, the unit for molar concentration is mol per dm cube. See that? If you don't want to write it this way, you could also write it like this. So this will be mol slash L. That is a capital L, or the uppercase for liters. So this is pretty much similar to dm cube. Just hold that at the back. Now you could also have a situation where you need to express the molar mass in terms of mass concentration divided by molar concentration. So this is also another formula you need to know. Of course, we're coming to calculations under volumetric analysis. So right now I'm just trying to brush through your brain with some of these nuggets. So molar mass is equal to mass concentration divided by molar concentration. So yeah, that's what you have. Now, of course, you can actually flip through many things to find out why the unit for molar mass is really gram per mole. You can actually find it from here. The unit for mass concentration is gram per dm cube. Okay, so I need to take out the negative. Yeah. Then the unit for molar concentration is mole per dm cube. So depending on whichever calculation you're actually given, you would have some of these things popping up. So for now, let's just let it lie. We're going to come back to it later on. Now, in order to be very fluid in volumetric analysis, you need to know some of these things. First, you need to know how to balance chemical equations. If you are able to perfectly balance chemical equations, then you would actually find little problem under this topic, volumetric analysis. Another name for volumetric analysis is titrimetry. So whichever way it's called with whichever text you're using, just know that the two words are basically the same thing. Now, the second thing you need to be very fluent in is a mathematical aptitude in stoichiometry. Okay, so we're actually gonna work a lot of stoichiometric questions, practice problems here. So you just need to hold that. And then thirdly, it's a basic understanding of titrimetry itself, right? So basically, what that means is, of course, all this stuff you have here that I gave you here, you need to have a good understanding of them. Or I should rather say, by the end of the class, you should be very good in balancing chemical equations, solving questions under stoichiometry, and being able to understand concepts under titrimetry. So that's the basic target. Now we're going to move into the first one. That would be the first section, balancing chemical equations. So there is actually a list of some of these chemical equations I wrote out, and we're basically going to practice it. So the first one, you have propane is combusted in oxygen, obviously, and that gives us carbon 4 oxide with water. So this is what you have. Now you need to balance it. Now the principle of the law of conservation of mass is basically what defines balancing of chemical equations. Because that law says that matter, well, sometimes you could say the principle of conservation of matter. If you don't want to say principle of conservation of mass, whichever way you want to call it, is basically the same thing. So actually what is involved there is that you need to have the same number of atoms on the left hand side of that chemical equations as there is on the right hand side. So basically that is the idea. Now in this case, as you can see, we don't have the same number of atoms of each element present on both sides being exactly the same. As a matter of fact, we don't have none of them being equal. For carbon here, we have 3. On these other side, we have carbon to just be 1. For hydrogen, we have 8. Okay. But on this side, we have 2 hydrogens, only 2. For oxygen, we have 2 on this side, and on the other side, we just have 3. So as you can see, there is a whole lot of differences on both sides. So what we need to do is bring it back to a point where we'll be able to have all the atoms being the same for each element on both sides. So let's start with the first element. That is a carbon atom. We have 3 atoms of carbon on the right hand side, but on the left, we have 1. So basically, we just want to increase the right hand side. This is the right hand side. Maybe I mistook that. So we need to make 3 mole of the carbon 4 oxide so that we can obtain 3 atoms of carbon on the right hand side. So this is what we're gonna have. That will be CH or C3H8 O2, and here now we're gonna have 3 CO2. I think I need to write that using green. Okay. So this is what we have, and of course we got water there. Now we have balanced carbon, but we're not done because there is hydrogen and oxygen. For hydrogen on the left hand side we have 8, but on the right hand side we just have 2. So basically, I believe we just gotta place a 4 in front of water. That gives us 2 multiplied by 4. That gives us 8 hydrogens. So carbon and hydrogen, they have all been balanced. The problem now is oxygen, right? So here we have 6 oxygens. Here we have 10. Whoa, this is 4 rather. So if you add this 2, obviously you're going to have 10. So this is actually 10 oxygen atoms. We need to balance that out. So this now will be C3H8 plus so there should be 5. So we have 5 oxygen molecules, and here we're just gonna have 3. So this is 3 moles of the carbon 4 oxide and 4 moles of water. So this will be the answer. That is the balanced form of that equation. Now let's move on to other ones. Now feel free to pause the video and try working some of them out on your own. That's going to be impressive. So you have aluminum reacting with hydrochloric acid, and this gives us aluminum 3 chloride with H2. So as usual, we need to find out how many elements we have on both sides. From here, we just got 3 elements on both sides, right? We have aluminum, we have hydrogen, and chlorine. And that's pretty much what is on the right hand side as well. Now for the left hand side, we have just 1 aluminum. On the right hand side, we also got just 1 aluminum. So aluminum don't got no problems. The problem now starts with the hydrogen. We have just 1 hydrogen atom on the left hand side, while there is 2 for the right hand side. So we just need to place a 2 in front of the hydrochloric acid. So that should be something like this. And yeah, right? So this is what we have. Now, we would actually say that we have balanced hydrogen and aluminum, but there is a problem because there's 3 chlorine atoms on the right hand side, while there is 2 for the left hand side. So there is a problem here. Now, how can we change this? So the first thing we're going to do is there is 2 chlorines on the left hand side. There is 3 chlorines on the right hand side. I'm going to take the left hand side and multiply it with 3, and I'm going to take the right hand side and multiply it with 2, so that we're going to have 6 on the left and 6 on the right. So that gives us 6 HCl. Here also we're going to have 2, because that is only what is going to create a 6 chlorine atom on the right hand side. So this is what you have. Yep. So right now we're actually going to say that, yeah, we have balanced chlorine atoms, but that obviously has created more problems. We have 2 aluminum atoms now, and I think that should really just be simple balancing that out. You just need to add a 2 in front there. Then for the hydrogen atoms, which are 2 on this side, while there is 6, right? So we just need to place a 3 in front. So that gives us 2 aluminum plus 6 HCl and 2 aluminum chloride, and this is 3H2. So this is the balanced form. This is the balanced form of the equation. Okay. Let's try another one. Yeah, so this is the next chemical equation. How can you balance this? So this one looks a little bit more scary than the other ones that we solved. And as a matter of fact, I'm actually going to teach you another way that you could use to solve this. So first thing I'm going to do, I would actually apportion various letters to each coefficient of these molecules. That would really go a long way, helping us to find the definite answer. And basically that helps you reduce the length of time that you use in trying to figure out what would be the balanced form. So let's say for the first one we have X of sodium phosphate. Then let's say we have Y of magnesium chloride. Then Z of sodium chloride plus, let's say we have a W of the magnesium phosphate, right? Yeah, so something like this. Now, what we are going to do from this place, we're going to try to isolate each element and find out what will be the number of atoms we have from this equation on both sides. So let's start with sodium. Now for sodium on the left hand side, we have 3 multiplied by x in it. So that gives us 3x. This is what you're going to have. Now all these other ones, of course, you can see there's no more sodium atoms on the left hand side. So let's go to the right. On the right, we have 1 atom, and that will be multiplied by z. So that says 3x is equal to z. Now the next one is obviously phosphorus. Excuse me. So for phosphorus, we have just x, because this is 1 atom. That is multiplied by the x here, so that's just 1. On the other side, we have 2, so that will be 2 multiplied by 1. That gives us 2. And then we multiply it finally with the coefficient, which stands for the number of moles. So that is 2W. Next one is oxygen. Now for oxygen, we have 4 atoms of oxygen, and obviously that should be multiplied by x. So this is 4x. On this side, we have 2 multiplied by 4. That gives us 8. And then that will be multiplied with W, so that is 8W. Now, this is actually the same thing with what we have here. Don't you think so? Because we could actually reduce this. Okay. So I think I'm going to use this. So this changes. If we divide through by 4, we're going to have x to be equal to 2W. So pretty much the same thing. Now, next up, we have magnesium, right? So for magnesium, we have just 1 atom multiplied by y. That's going to give us the y. Then on this side, we have 3 atoms multiplied by W. That will be 3W. And then we have chlorine. There's 2 chlorine atoms multiplied by Y. So that gives us 2Y. On this side, we have 1 atom. So that will be 1 multiplied by Z. That's just a typical Z. So the main thing you got to do, you just feel free to restrict one of the letters to 1. So let's start with X. Let's say X is equal to 1, right? So we need to save that somewhere. Now, if X is equal to 1, let's use it for the first equation. Or let's just go on. Well, we could actually go on with whichever equation of our choice. So for this one, if we say that x is equal to 1, then using it in this equation, this will be 3 multiplied by 1, and that's equal to z. So we therefore know that 3 is equal to z, and therefore z, that will be equal to 3. So this one is important. Now, we also have stuff that can lead us to find what y is. We know that 2y is equal to z. Z now has been found to be 3, so that's 2y is equal to 3. So to get y, I'll divide both sides by 2. That will give me 3 halves. So y is equal to 3 divided by 2. Y is equal to 3 divided by 2. So I need to write that there. Save that out. Next up, we have x dependence on w. X, that's equal to 2w. And x is equal to 1. So 1 is equal to 2w. And w will be equal to 1 half. You basically need to divide through by 2. So w is equal to 1 half. Alright? So now we have everything. So let's plug it back in. So for x, we have 1. So we're really just gonna write it as it is. And y, that is 3 halves. That is magnesium chloride. And then we have z, that's 3. So that's gonna be 3 sodium chlorides. And then we have w, which is 1 half. So that will be 1/2, right? 1/2 magnesium phosphate. Okay, so this is what we have. Now, this is not completely balanced yet because you don't have fractions as a coefficient of chemical substances. So what you need to do here is take the LCM of fractions that will be present in a chemical equation and use that LCM to multiply through to every term or every molecule in that chemical equation. In this case, we have 2 as a denominator, and there is also a 2 on this other side. So obviously the LCM is 2, right? So we need to take 2 and multiply through all this equation with it. Now if we take 2 and multiply with this, that gives us 2 sodium phosphate. And 2 multiplied by this is 2 multiplied by 3/2. Obviously that is going to cancel the 2's away, and we should have 3 moles of the magnesium chloride getting formed. So this way you have, right? Next up, you have 2 multiplied by this. That gives you 6. So that will be 6 sodium chlorides. Next up, you have 2 multiplied by half. So it's typically just trying to say that half of 2, which is basically a 1. So we don't gotta write nothing there. We just leave it that way. So this is basically what we have. This is what has to be the answer. Now we're gonna try to find out whether or not this is correct in it. So let's wipe some stuff out here. I'm gonna find out what this is. So on the right hand side we have sodium. Sodium is equal to 6. Here we have phosphorus. Phosphorus, that is 2 multiplied by 1 here. So that is 2 phosphorus on the one side. For oxygen we have 4 multiplied by 2. So oxygen, that will be 8. Then we have magnesium. Magnesium, that is 3. Then we have chlorine. Chlorine, that will be 2 multiplied by 3. So that gives us 6. Then on this side again, let's see what is going to be formed. So we have 6 sodium. So of course, sodium is balanced now. Then we have chlorine. Chlorine is 6, right? So this is going to be chlorine. I think I should just make it a bit more homogeneous. So this is P, this is O, this is Mg, and this is Cl, right? So for phosphorus, we have 2 multiplied by 1. That pretty much well gives us this stuff here. This gives us 2. So I'm just going to say 2, right? Yeah. So let's find out. Well, that's correct. Now oxygen, this is 4 multiplied by 2. That gives us 8. And that was what we had for the left-hand side. The magnesium, we have 3, basically. And it's also 3 we have. Well, this is 8, this is 3. Then we have chlorine, which is 6. So of course, this is completely correct. So this stuff is completely balanced. I believe you basically understand everything we did here. So now let us go on to, we just got some 3 more. Well, mistake. So yeah, next one is ammonia is reacted with oxygen, and that produces water and the nitrosonium gas. So what is going to be the balanced form of this one? This one is pretty simple. You should be able to work it without using algebraic formula. So nitrogen should be balanced first. In this case, nitrogen is already there, so there is no problem with that. And there is a problem with hydrogen. There is 3 hydrogens on the left-hand side, while there is only 2 on the right-hand side. So basically what I need to do, maybe I just need to, so we got 3 here, while there is 2 here. So as you know, this should be 3 multiplied by 2, and this should be 2 multiplied by 3, right? That means we need to form 6 hydrogens on both sides. How can we make 6 to be formed here? We need to place it 2 in front of ammonia. And here we need to place a 3 in front of hydrogen. So let's try to do that. So this will be 2. That will be 2NH3 plus O2. And on this side we need to place C. That will be a 3. So that is what we have. And the problem now will be for nitrogen. So we have created 2 nitrogens here, and we need to balance that out. So I need to rewrite that. Okay, so I need to place a 2 there. So this is a 2, of course. And so now we have 3 oxygen there and 2 oxygen. So that is 3 plus 2, right? So 3 plus 2, that gives us 5. So we need to create 5 on this side. There is already 2. So if we take 2, multiply by 5 halves, this cancels out. So we can basically do that. So here we should actually have the 5 half. So that is what we have. But of course, you know that we cannot have fractions as coefficient of chemical substances or reagents. So we need to take the denominator and multiply through everything with it. So let's do that. 2 multiplied by this, that will give us 4. So that will be 4NH3. Here we have 5 basically being formed. So that will be 5 half multiplied by 2, which basically gives us a 5. So that's what we have. So I really struggle to write 5 on this app. Yeah, 2 multiplied by 3, that gives us 6. And then we have 2 multiplied by this, so that gives us 4NO. Now nitrogen is 4 on this side, nitrogen is 4 on the other side, that's correct. Hydrogen is 12 on this side, correct. Hydrogen here is also 12, that's correct. You got 10 oxygen here, you got 6 oxygen, 4 oxygen, giving you 10. So we're pretty much correct. Everything is okay. So this one is the correct form of the answer. Now let us go on to the last ones. We just got 2 more. Feel free to pause the video and try working out this one by yourself. You got nitric acid, and that were reacted with this stuff, baking soda, and you form sodium nitrate plus carbon 4 oxide plus water. Carbon 4 oxide actually evolved, so we need to place that there. I think I need to maybe I should just take this. Yeah, so that is what we have. So what is gonna be the answer? How are you gonna balance this? So let's find out what's going on. Here we have 2 sodiums. We just got one here. So we might well just place a 2 in front of this. If we place a 2 in front of this, this gives us 2 sodiums. And so we are good there. Nitrogen would also need to be 2, so we'll need to place a 2 here. And that would create 2 hydrogens. And these are the 2 hydrogens here. And the next thing will be carbon. Fortunately, carbon is 1 on this side, and we still have just 1 of it on the other side. So we don't have a problem with carbon. So the last one now is oxygen. There is 3 oxygen here. There is another 3 here. But you know, this is multiplied. So this gives us 6. So that's a total of 9. On this side, we have 6 again. Then here we have 2. And here we have 1. So this gives us 6 plus 3, 9. This plus this, 9. So we're actually correct for everything. So this one right here is a balanced form. Let me rewrite it. So this will be the balanced form of it. Okay, so that's what you have. So try working out this one by yourself. Find out what will be the balanced form of this. And also try to work out what will be the product of this one. So try to find out what will be the product. What would you form? So if you do that, just send the answers to me.